Okay, so let's talk about how to fit this robust regression model. So the first thing I'm going to do is load the Fairway package. I'm going to say like load data. So I'm going to load the Fairway package, and let's take a look at that data set that we're going to be using. So there's a whole bunch of different variables here. If I look in the console, I can learn a little bit more about it. So this is data from 30 Galapagos Islands that include 7 variables. It's trying to assess the relationship between the number of plant species and lots of geographic variables. Okay, so that's how we're going to load the data, and let's also just go ahead and fit the model here. So we're going to fit a robust regression model to that GALA data set, or GALA, I guess, for Galapagos, predicting species using area, elevation, nearest, struts, and adjacent. So the robust regression, that is in the mass package, so I'm going to go ahead and load that as well. If I do RLM, so instead of GLM, we're using RLM, or instead of LM, we're using RLM. So RLM is robust linear model, and we're going to predict species using area, elevation, nearest, adjacent, data equals GALA. So there we go. It looks like it worked. I'm going to save this as mod here so that we can look at some different pieces of it later. Okay, which observations result in weights less than 1? So I actually had a mistake in the slides. I said to look at mod weights. If you look at that, that's not the right piece to look at. We actually want to look at mod W. That's going to be the right one. And so that was a typo on my part. And so what you're going to want to look at is this W object within the mod fit. And if we notice here, we see there are a couple observations that end up with weights less than 1. And so we can see kind of which ones those are. For example, we can actually index our data set if we'd like to. So we can take the whole GALA data set and we can index it using, we can use a logical statement here. So we can say mod W is less than 1. And so what that's going to do is if I just run this part, it has a bunch of true false. And so anytime it's less than 1, it's true, and otherwise it's false. And so when I index this data set, I'm basically selecting the rows where that's the case. So I can see kind of what that looks like. And so it looks like there are 7 rows here that correspond to the 7 islands where this is the case, where the results, the observations result in weights less than 1, which suggests that maybe these observations, which this gets at the last question, that suggests that these observations they're being downweighted when we use robust regression, which suggests that perhaps they present as something like outliers. So for example, just so I could see kind of what this would look like if I fit a linear model, so let's take that model that I fit up here, and instead of fitting robust regression, I'm just going to fit a linear model here. So this is the exact same, except instead of using the RLM function, I'm just using the LM function. I'm going to call this mod LM. And so now if I wanted to do a plot of the residuals, I can create a data frame where E can be the residuals from this mod LM. And let's look at a residuals versus fits plot. So fits is going to be the fitted values from this mod LM. And then I'm actually going to also have I'm going to use the names of the islands so that we can see kind of what that looks like. And so this is going to be like island or something, and that's going to be the row names of the GALA data set to tell us what those are. So let's call this data frame D. Okay, so what we have here are the island, the residuals, and the fits. We can use this data frame in a plot. So I'm going to load the ggplot2 package. And let's try to figure out let's try to create a plot to see about outliers. So one that we can do is a QQ plot, if you remember that. So I'm going to plot the data frame, and now I'm going to use sample equals E for the residuals. I'm going to use geom QQ, and then I'm going to do geom QQ line. Okay, so this shows us basically these ones that sort of deviate from the line here are going to be ones that are kind of a little bit more problematic. So kind of up here at the top and at the bottom. And so let's see if it rings true that those ones are kind of match what we're seeing here in these ones that are being called out here. So to make it easier, I'm gonna do a little bit of ggplot magic to be able to actually label these. And this is a little more complicated because we're using some under the hood functions here instead of calculating. If we had just calculated the quantiles ourselves, this would be easier if we just stuck them in the data frame, but we haven't. So we're gonna do a little bit of ggplot finagling. So I'm gonna save this plot here as P. And what I'm doing is I'm extracting the data set from this plot so I don't have to create it myself. And so to do that, there's this function called ggplotBuild that I can use. And so I'm going to do ggplotBuild. And I'm going to pull out the build from this plot. And what I actually want is the data from this. And so if I just run that, you'll notice here I get this data set that includes my X, my Y, the theoretical, the sample values that we're going to be actually plotting. I'm going to call this D2. It's my new data that I want to plot with. So let's save that. And then I want to add these labels here, these island names that I pulled out. And so I'm going to say D2 island, and that's going to be equal to D island. And we want to make sure the order is right. And so I'm going to do order E, because this is going to be, if you notice, if you look at this plot or this data frame, it's in order. Our residuals have been ordered here, so we want to order them here. Okay, and now let's plot this new one. So D2, we're gonna plot on the x-axis. It's gonna be the theoretical. On the y-axis is the sample, and now I want to label this with the island name. So I'm going to use, I'm going to use this geom text, which is going to actually label those values. So there we go. So now we have these values. Some of them are a little bit scrunchy and hard to see, but you can see at the top here we have Santa Cruz, we've got Santa Maria here, San Cristobal, and then Gardner 1. And then down here at the very bottom we have Pinta. So let's take a look at our data frame here. We've got Gardner 1, Gardner 2, Pinta, San Cristobal, San Cruz, Santa Maria. So it's exactly kind of what we would expect, and the tails are where these ones that ended up getting up and down weighted are taking place. And if we look, let's look at this mod W again. Let's see. So this, let's look at the one that's the smallest. So let's say we want where mod W is equal to the minimum value. So that's Santa Cruz. So if it's the minimum, that means it has the smallest weight. So it's being downweighted the most. And so looking at this plot, where would you expect that one to fall? Well, you'd expect it to be the one that deviates the most, which is exactly what happens here with Santa Cruz. We see it up at the top. So that kind of confirms what we expected to see.